Hello again, everybody. This is Mr. R. We're going to have another screencast lecture tonight. This one's going to be a little bit different because I'm having problems with my camera and my drawing tool and all that kind of stuff. So this is certainly not going to be my best work. If this is the first time you're seeing one of my screencast lectures, please check out some of my other ones. They are definitely of better quality, but we'll do the best we can. Let's get started. First thing we need to do is to think about the idea of speed. Now I have a picture here of a hummingbird. If you think about that, they obviously will flap their wings at extremely high speeds. And there may be some other things you think about speed, like the speed of a car, maybe a race car, maybe a jet plane, maybe riding your bicycle, or sprinting, like maybe Usain Bolt. Let's take a look at an amazing animation here. Let's take a look at Smurfette. Smurfette is going to tell us the definition of speed. Speed is the change in position and how long it took the object to make that change. And what I mean by that, if you take a look at Smurfette, Smurfette is going to start changing position. She is changing position relative to the starting point, and that's something that we spoke about in a previous lecture, relative motion. So this is our starting point. We're going to assume that that is our point of reference, and she is now moving away from our point of reference, and she is moving closer and closer to the finish line, and she made it. Good job, Smurfette. Now, to be able to figure out her speed, to be able to calculate her speed, we're going to need two different measurements. What information are we going to need to know? One of the things that we're going to need to know is how far that she traveled, how far she went from here to there. And the second thing we're going to need to know is how long it took her to make that distance traveling. So we're going to need to be able to know the distance from the start to the finish, and we must know how long it took her to make that trip. And in this case, let's just assume that she went 5 meters. She went from here, this is 0 meters, to here 10 meters. Let's assume that it took her 5 seconds to do that. What is her speed? Well, you might be able to figure out that if she did 10 meters in 5 seconds, maybe think about how far she went in 1 second. Well, that's something you might be able to figure out in your head. Well, she went 2 meters every second. And so her average speed is going to be 2 meters per second. Here we can see that speed is not directly measured. We had to calculate it. We had to do a division. We had to do some sort of calculation of her distance as compared to the time. And since it is a calculated measurement, we need to have some sort of a formula for it. And the speed formula we are going to use is average speed, and we're going to use the formula average speed is equal to distance divided by time. And a good way to abbreviate that would be S for speed is equal to distance divided by time. Each calculation for me is going to be worth 4 points, and in the past we've talked about this where you have to show your work, quote unquote. And by that I don't mean like maybe like in your math class where you need to say 12 times 2 is 4, and then 1 times 4 is 4, whatever. That's not what I'm talking about at all. What I'm talking about is a way for you to show me your work, and it's also a really good way to assure that you're getting the right answer. So we're going to use what I call the plug and chug method. And in this case, we are going to look at a situation where, let's say we travel 200 miles, and the time elapsed to make that trip is going to take us 5 hours. So if we use the formula, the first thing we need to do to find our first point is to write down the formula for speed. And we know that the formula for speed now is speed equals distance divided by time. And then what we're going to do is we're going to plug in our values. So we need to plug in the value for distance, and then we need to plug in the value for time. Our value for distance was 200 miles. Our value for time is 5 hours. We just earned the second point. So now we've got 2 points, and now we need the third point. We need to do the chug. We did the plug. We plugged in 200 miles. We plugged in 5 hours for time. Now we need to chug, so we're just going to use our calculator. I strongly encourage you to use a calculator. 200, and then hit the dividing sign, hit 5, hit equals, we get 40. And if you wrote the units in here as you did the plug, you will also be able to see the final unit that you'll need, which is miles over hours. And then we see that that is the correct unit. So 40 miles over hour, and we'd read that as saying 40 miles per hour. And then after you have that 40 miles per hour, we want to circle our final answer. So 40 miles per hour is our final answer if we travel 200 miles in 5 hours. And that brings us to the idea of units of speed. Now, units of speed can be very, very many and varied. Probably the most common you could think of is what? Right, miles per hour. That's probably the most common unit of speed that you're going to think of that we use on a daily basis. We can abbreviate that in many different ways. One good way to abbreviate it would be MI over HR. I like to use MI instead of M so you don't confuse miles and meters. Miles/hour is another way you can do it. That's a good way to do it, especially if you're typing it. It's really easy to write that out. And then you probably have been familiar with this miles per hour MPH, and that's fine, that's okay. However, I do not want you to use this one, please, because it doesn't work as nicely for other units of distance and time for speed, like let's say we do kilometers per minute, meters per second, etc. It just doesn't work very well. So please do not use this abbreviation. Use like miles over hour, miles MI over HR, or miles per hour / and that kind of good stuff. Let's do another practice. And in this case, we have a horse. The horse is going to run 12 kilometers, and it's going to do that in 8 hours. Calculate the horse's average speed, and be sure to earn all 4 points. This would be a good time for you in your notes to just try it out. Go ahead and work out the problem. I'll come back to it again. Work out the problem. Remember, the first thing you want to do is to write the formula. Second, you want to plug in the values in that formula. Third, you want to use your calculator to plug in to chug to calculate the numbers. And then finally, you get your final numeric answer and your final unit. Okay, if you want to pause it here and take some time to work it out on your own, great. I encourage you to do that, but here's the answer. So in 3 seconds, I'm going to show you the answer. So get ready. 3, 2, 1. Here's the answer. You earn the first point by writing the formula. Speed equals distance divided by time. You plugged in the correct answer. Speed equals 12 kilometers per 8 hours. And then our final answer is 1.5. And the correct unit would be kilometers per hour. And of course, I circle my final answer, and I get all 4 points. Here's another way to use the formula. This is just rearranging the exact same thing of speed is equal to distance divided by time. We could rewrite it as either distance equals speed times time, or time equals distance divided by speed. Go ahead and write those down. We're not going to use those in this installment of Screencast Lecture, but it is definitely 2 formula formats that you will definitely use in future use. Boy, that's kind of redundant, use in future use. How about that? All right, so anyways, units of speed. You can use any unit of distance divided by any unit of time. And you could think of tons of examples for this. Meters per second, meters per minute, meters per month, meters per year, meters per decade. I mean, it doesn't matter. If you think of a snail, maybe a snail is going to go a meter per hour. Or even, centimeters per hour for something quite slow. Erosion could be something that's very, very slow. So you might want to do something, centimeters per year. That would be a good one when you're talking about continental drift, things like that. Any unit of distance over any unit of time is appropriate. Here are some examples that, you might have thought about just right off the top of your head. Miles per hour, kilometers per hour, meters per second, feet per second, centimeters per year. Depending on what you're doing, what you're measuring, you might want to choose the more appropriate unit. And one of the cool things about the units of speed is it also is a good way to help you to remember the actual formula. So just in case you've forgotten the formula, like for example, the most common unit of speed that we here in the United States use is probably what? Right, miles per hour. So if I write that miles per hour, like I've shown you, miles over hour, and then we think about that miles is a unit of distance, an hour is a unit of time, then we can write that out. We abbreviate distance with a D, and then we abbreviate time with a T, and lo and behold, there's your speed formula, distance over time. So keep that in mind. That's an easy way and a good way to remember the formula just in case you have forgotten it. Now let's talk about instantaneous versus average speed. If you drive, for example, 200 miles in 5 hours, this is the thing that we did before, your average speed is 40 miles per hour. What that means is that I've averaged a distance of 40 miles every hour that I traveled. That's why it's called average speed. Average speed is the total distance divided by the total time. Go ahead and write that down. Average speed is the total distance divided by the total time. Does this mean if I looked at the speedometer any time during my 5-hour trip, is it going to read 40 miles an hour? So if I look at my speedometer, is it always going to be reading 40 miles an hour? Why or why not? Think about that for a minute, and if you want to pause it, you may, and then think it. Here we go. We're going to go to the next slide and discuss my response to that. Well, no, you are not going to be going exactly 40 miles per hour during the entire 5-hour trip. If you think about it, during that 5-hour drive, you probably would have slowed down and sped up at some point during the journey. Maybe the person in front of you is not driving very fast, so you need to pass by it, or maybe there's an accident, you have to stop suddenly. So during that period of time, there's no question that your speed probably changed from 40 miles an hour. Instantaneous speed is the speed at a given brief moment of time. So as you're driving down the highway and you look at your speedometer, if it says 40 miles per hour, that is your instantaneous speed. That doesn't mean that's going to be your speed over the entire 5 hours. That is instantaneous speed. How fast your tires are spinning will determine your measure of speed on a car. So here's one of my favorite vehicles, a Jeep Wrangler. And here you see they've lifted the Jeep and they've added these really super big tires. Now the thing is, if you add big tires, that's actually going to goof up your speedometer. So normally your tires are this big. So 1 spin, 2 spins, 3 spins, that Jeep is going to go a certain distance. And your speedometer is keyed for that. But if we have this extra big tire, 1 spin, 2 spins, 3 spins, if the tire spins 3 times, the Jeep is going to go further than it normally would on a small tire. So if you're driving down the highway, your car may think that you're traveling 40 miles an hour, but you're really traveling 50 miles an hour. So if you do something like this and change your tires, you actually need to make some sort of change your speedometer, and so you know that you're driving the correct speed. And speaking of speeding and getting tickets and all that kind of stuff, one of the things you've probably seen on the highway, you've probably seen a police officer using a radar speed gun to attempt to measure the passing cars. What kind of speed? Is he measuring instantaneous speed, or is he measuring average speed? Well, he is attempting to measure instantaneous speed. He wants to know how fast is the car or the truck going at that moment that he points the radar gun at it and takes that measurement. Now, technically, it's still an average speed because of the way that speed is measured. However, it's such a tiny little window that we can go ahead and assume that it is instantaneous speed. Another thing that is pretty unusual, so let's say you have a road, and what they could do is paint a line on the road, and then down the way there's another line. Let's say it's 100 yards away. Here's this line, and then 100 yards away there's another line. What the person in the aircraft, the police officer in the aircraft, can do is they start the timer when the car hits this line, tick, 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 and then stop the timer when it hits this line. They now have the 2 variables that you need to calculate speed. You know the distance because they know the distance between these 2 lines. They painted it there, so they know the distance, and now they know the amount of time. So they could say 100 yards divided by 2 seconds or whatever it is, and then from that they can calculate the cars. What type of speed? Instantaneous or average? Well, in this case, this is going to be average speed because it's over a longer period of time. It's not something like radar, which is recording at the speed of light. However, that does work, and you can do that at a 50-meter dash. So if we come back to this, let's say you run a 50-meter dash, this is 0.0, this is the finish line 50 meters, so you would start the clock here, run, hit stop at 50 meters, you now know the distance, 50 meters divided by the amount of time, and you can calculate your speed. You can even calculate it in meters per second. You can convert it to miles per hour, etc., etc. Now, let's move on to our next term is velocity. Sometimes people use speed and velocity interchangeably, but they are similar. That's true. They are similar, but they're not the same. Velocity has an extra ingredient to it. Velocity is going to include speed of the object and its direction. For example, you could be going 2 meters per second south, or you could go 2 meters per second north. They're both the same speed, but they're different velocities because they're going 2 different directions. It could be 35 miles per hour east. It could be 35 miles per hour west. Again, they mean something different. In this case, if it's a car, one car is going 35 miles per hour east, one car is going 35 miles per hour west. Same speeds, different velocities because they're going different directions. So if you think about this, we have here, identify 2 ways that velocity can change. Well, we could either change the 2 parts of velocity is speed and direction. So we could change either the speed of the car, or we could change the direction that the car is going. So that's velocity. That's not a real in-depth discussion about velocity, but we'll get more into the velocity in the future. You must memorize that. Speed is equal to what? Hopefully you said distance divided by time. So speed is equal to distance over time. And that's all the time we have for tonight's screencast lecture. Catch you next time. See ya.